So let us see another braking method, that is plugging. So plugging is just nothing but we have to interchange any two phases of our stator supply so that the rotating magnetic field, the rotating magnetic field in the air gap field reverses its direction, and the direction will be opposite to the direction of the rotor. Okay, if this is the direction of the rotor, the rotating RMF direction will be this one. Okay, this will be opposite to rotor direction. That means our RMF will rotate in opposite direction to rotor rotation. Then our speed of the rotor, direction of the rotor also tries to rotate in opposite direction. Okay, so whenever the speed will become 0 and it will try to rotate in reverse direction, then we can disconnect the supply. Okay, that is plugging. Let us see the definition. Plugging braking is done by reversing the supply phase sequence by interchanging any two phases of the stator. Okay, that means initially let us say it is ABC phase sequence. If we can interchange this by interchanging this B and C, that will become ACB. Okay, so by interchanging the two phases, the phase sequence has been changed. Now what happens? Due to the reversal of phase sequence, the direction of rotating magnetic field RMF reversal, this produces torque reverse direction. Okay, then the motor tries to rotate in opposite direction. So while it is trying to rotate in opposite direction, initially it was this direction, now it tries to rotate in opposite direction. That means it has to come to stop first, then only it will come to rotate in reverse direction. So at that instant, when our rotor comes to start position, before it is going to rotate in reverse direction, we are going to disconnect the supply. So that is nothing but plugging. So we can stop the motor instantly. This is very instantaneous process of stopping, instantaneous, very fastest stopping, fastest braking. Among all three braking methods, this is fastest braking. But this braking will have effect on electrical braking, electrical mechanical concept, but okay, it cannot be used frequently. It is used whenever a motor is needed to stop instantly. Plugging is the fastest method of braking. Let us see practically what is happening. Now let us see what is happening while plugging. Okay, for phase sequence of ABC, so this is the torque slip characteristics of our induction machine. For phase sequence of ABC, that means the ABC phase of to the stator supplier ABC. So then it is a torque slip characteristics. Okay, torque on the y-axis and speed and slip on the x-axis. So okay, now we are going to interchange the phase sequence by interchanging any two phase. Initially it was ABC. Okay, initially it was ABC. Now the phase sequence has become ACB. Now because of the interchanging of the phase sequence, the synchronous speed will be shifted like this. Okay, this will be my new synchronous speed due to the interchange of phase sequence. Okay, now let us see what is the characteristics. What are the new characteristics of our induction machine due to the phase sequence change. So this will become our new NS. Okay, so this will become my generating characteristics. Okay, this is up to this point, this is the motoring characteristics of our new phase shifted machine. This will become our generating characteristics, generator region, I think. Okay, all up to this. Okay, now what is happening here, you can see initially this was my operating point under ABC phase sequence. Okay, now the operating point will be shifted to this point because our new electromagnetic curve is met with our load torque. This is our load torque curve. Here, this is our new stable operating point. Okay, this was our speed of the rotor NR under ABC phase sequence. This will be our new speed of the machine, that will be NR dash. This is NS dash, new synchronous speed, and this is new speed of the rotor, that is NR dash. So the speed of the rotor has to come back to this position. Okay, you can see just after changing the phase sequence, the rotor speed has changed from NR to NR dash and synchronous speed changed from NR to NS dash. Okay, it was in first quadrant for ABC sequence, it is in the third quadrant for ACB sequence. Okay, so now let us see what is happening here. Okay, so initially the operating point for ABC sequence is A. Now it has to come back to point B for the phase sequence of ACB. So let us see what is the behavior of the machine. So instantly it cannot come back to B as the rotor of the machine has some inertia due to the speed rotation. Okay, it cannot stop and come back to some another speed position instantly. So for that it will come back to this position. Okay, here this is our new speed NR and this is the slip of the machine. Okay, here. Okay, so the rotor slowly reduces its speed and tries to come back to point B. So in between it will come back to point O. Okay, in between it will come back to point O. After this our rotor will go back to point B. So at this position you can see here, so at this point our speed of the machine will become 0. Okay, so at this point I am going to disconnect the supply. Okay, and one more thing is plugging is nothing but reverse current braking. Reverse current braking. Plugging is called reverse current braking, and slip in plugging is equal to 2 minus S. So this is slip at plugging. These two are important questions for competitive exams. Okay, plugging is also called as reverse current braking, and it is the fastest braking method. Plugging is fastest braking method among 3 braking methods. Okay, so this is the plugging, this is slip at plugging. 2 minus S is slip at plugging. Okay, we will try to derive it. So this is about plugging.